Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List published on December 19, 2025, about 3 days ago. This paper introduces the laws of reasoning, plus a new LoRe bench evaluation, and it shows that while most large reasoning models look monotonic, they broadly fail compositionality, and a targeted supervised fine-tuning called SFT compo can cut compositionality deviation from 0.528 to 0.314 on a 1.5B model. The paper is titled, When Reasoning Meets Its Laws, and as we will see later, the implications for how we train and judge reasoning behavior are pretty significant. Also, the authors shared a companion GitHub repo for LoRe. Right now, it mainly includes the project README and some site assets, with an overview of the laws of reasoning idea and LoRe bench. The key note is that the code release is still under construction, so implementations and models are not posted yet. Figure 1 shows why the authors think reasoning behavior can look irrational, because the model spends tokens in a way that does not match how humans break problems into parts. The left panel shows question 1, a simple sum, which uses 525 reasoning tokens and reaches 75% accuracy. The middle panel shows question 2, squaring 55, which uses 197 tokens and gets 38% accuracy. The right panel combines them, but the model only uses 817 tokens and accuracy shifts to 50%, so compute is not additive across subproblems. Figure 2 turns that intuition into two simple laws you can test. The full graphic lays out compute law and accuracy law, where compute means reasoning tokens, and complexity means how many primitive steps the task really needs. The left plot shows compute rising roughly linearly with complexity, and the middle plot shows accuracy dropping as complexity grows. The right side reframes both laws into checks, monotonicity and compositionality, so independent subproblems should add compute and multiply accuracy. Table 1 puts real numbers on monotonicity, meaning harder question variants should make models use more reasoning tokens and achieve no better accuracy. The full table reports Spearman correlation, which is a rank-based score where values near 1 mean the trend is consistently increasing, and negative values mean it reverses. Most models look strong on reasoning compute overall, but DeepSeek R1 1.5B breaks in language and code. The log accuracy correlations are mostly negative, which matches the law. Table 2 shows that compositionality is where these models really struggle, even when monotonicity looked fine. The key metric here is normalized mean absolute deviation, which measures how far the model is from the ideal add-up or multiply behavior, so lower is better. The left numeric column says reasoning compute is not close to additive, with DeepSeek R1 1.5B at about 0.528. The right numeric column says log accuracy deviates even more, reaching about 2.37 for that same model. Figure 6 means that supervised fine-tuning can make a model's token spending behave more like adding two independent subproblems. Normalized mean absolute deviation is a distance to the ideal additive rule, so lower values mean better compositionality. The left bar chart shows drops after SFT compo, including 1.5B going to about 0.314. The two scatter plots show why the SFT compo points hug the y equals x line more tightly. Table 3 shows that pushing models toward compositional token use also boosts real benchmark accuracy. The full table compares base, plain supervised fine-tuning, and SFT compo across math and science tasks, where pass at 1 means the model gets the answer right in one sampled attempt. In the DeepSeek R18B block, the average pass at 1 rises by about 5 points under SFT compo. The orange deltas show that SFT compo beats the control supervised fine-tuning in every model block, so the gains are not just teacher distillation. Alright, two takeaways stand out. Most large reasoning models scale compute in the right direction as problems get harder, but they still fail compositionality, meaning token use and success do not combine cleanly across subproblems. The broader implication is that training and evaluation can target these reasoning laws directly, and simple fine-tuning can improve both behavior and accuracy. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.